Hi friends, welcome to my channel NM Learn Courses with Nagamani. Today we are going to see how to find the reaction forces at point A and B for the loaded beam as shown in this figure. Okay, we in this problem we are going to find the reaction forces at point A, point B. Okay, so here they are given, one is hinged support and another one is roller support. And we know that for hinged support we have two reaction forces in horizontal and in vertical direction, and for roller support we have only one reaction force in vertical direction. Okay, I am going to draw a free body diagram for this here. For a reaction force for A, here we have hinged support, so we have vertical and horizontal. So vertical reaction force, that is RAY, reaction force at A point in Y direction. The next one is RAX, reaction force at point A in X direction. Okay, and here we have at 2 meter, here also at 2 meter, and here also at 2 meter. In each 2 meter we have the forces. Okay, and here we have roller support. So for roller support we have only one vertical direction, that is RB. So I am representing with RB, no need to write RBY because only one reaction force acting at B. Okay, and next one is, here we having only one vertical downward force, so I am writing one downward force, that is 100 newtons. So here we having uniformly distributed load. So we know that how to convert uniformly distributed load into point load, that I have explained in the previous classes. So who did not watch that classes, please visit, then only you can understand how to convert uniformly distributed load or uniformly varying load into point load. So I will also explain here once. So for converting uniformly distributed load into point load, we need to multiply this load with the distance. So 10 Newton per meter, so it is acting 2 meter length. So in this span only, this load is acting. So 10 into 2, 20 newtons. We got the force 10 into 2, that is 20 newtons. So here meter get cancelled, so we will get 20 newtons. Where this force will act, so this is uniformly distributed load, so it is, we can say that, rectangularly active load. So where it will act rectangularly distributed load, it will act at this center. So here 2 meter, in the length this is acting, so center means at 1 meter. So at 1 meter distance the load is acting. How much load? 10 into 2. So 20 newtons of load is acting at this center for uniformly distributed load. We wrote this load and this load. Next one is, we have momentum here. So we directly write momentum at this point. Okay, at this point we have 100 Newton meter. Okay, and here we have one inclined force. We did not saw this type of forces till now. So we know that for inclined force it can be resolved into two components. One, in here we have inclined force, so it can be resolved into two components, in x direction, in y direction. So here the angle is with the x direction, which is 45 degrees. So we know that for wherever the angle is acting, that side we have cos sign. So force is 141.4. So here we have cos 45 and the remaining one is 141.14 sin 45. In this way we can resolve any inclined component into this horizontal and vertical components. So here we have one vertical force, that is 141.14 sin 45, and the next one is horizontal, so that is 141.14 cos 45. Okay, and this is 2 meter length, this is also 2 meter length. So we converted this diagram into free body diagram. So first we need to find this reaction force RAX, RAY and RB. So we need to find the reaction forces at A and B points. Okay. Now we know that with the help of this static equilibrium forces we can find these reaction forces. We know that the static equilibrium forces are sigma Fx equal to 0, sigma Fy equal to 0 and sigma momentum equal to 0. So sigma Fx means forces acting in x direction is equal to 0. And for solving this problem, first we have to take the sign conventions. So we know that graph. So for right hand side this is positive x and for left hand side negative x, and for upward force positive y and down one is negative y. So in these signs only we will consider the for this reaction forces for every force. And for we are assuming here for clockwise direction is negative and anti-clockwise direction is positive. Clockwise means clock will be in this way, anti-clock means in reverse direction. Okay, these signs you have to remember while solving the problem. First we have to convert this diagram into free body diagram, and for free body diagram we need to convert every reaction forces into this point loads, and next we have to know this sign conventions. Okay, for this sign convention only will make this so much difference for the answer. And so first we will see forces acting in x direction equal to 0. So if we see here we have RAX and 141.414 cos 45. Only we have two reaction forces, like two forces in horizontal direction we have. So we know that this is in positive x direction. So RAX, and here we have negative direction. So we see that it is in negative direction. So minus 141.14 cos 45, and we don't have any other force, so equal to 0. This is the first static equilibrium condition. From here we got RAX which is equal to 141.14 cos 45. We know that cos 45 equal to 1 by root 2. Sorry. We know that cos 45 is nothing but 1 by root 2. We know, okay, 1 by root 2, or we can calculate in calci also. Okay, how to calculate in calci we will see now. Okay, 141.14 into cos 45. So here we have cos sign, so with 45, so which is equal to 99.80. okay, we got 99.8, so which is equal to 99.8 newtons. So here we have Newton sign, so we got newtons. RAX equal to 99.8 newtons. We got one reaction force, and we have to find the RAY as well as RB. So reaction forces in y direction equal to 0. We will use sigma Fy equal to 0 now. So if you see the diagram here, RAY which is acting upward. So for upward force we have positive. So here RAY. Next one is which is acting downward. So minus 141.14 sin 45 is nothing but 1 by root 2. And next one is here also downward force 20 newtons, minus 100 also downward force, and RB is upward force which is positive. So RB, really sorry. Okay, first one is RAY which is acting upward, so positive, and next one is 141.14 sin 45 which is acting downwards, so we are taking minus, and next one is 20 newtons which is also acting downwards, so minus 20, 100 newtons which is also acting downwards, so we are taking minus 100, and RB which is acting upward, so we are taking plus RB which is equal to 0. So from here we can write that RAY plus RB, which is equal to, here I am taking everything into right hand side and I am adding now. Okay, see, if you see here 141.14 into sine 45, you know, sine 45 plus here 100 plus 20, 120. So overall 219.8. Okay, 219.8 newtons of force. We got one equations with two unknowns. So we know we have one more equation, that sigma m equal to 0. So I redraw the diagram here. Now here I wrote that from sigma fx equal to 0, this equation we got RAX value as 99.8 and sigma Fi equal to 0. From this equation we got RAY plus RB equal to this much value, and now we are going to see sigma moment equal to 0. And now moment, I am taking moment about a point. Okay, moment about a point. We know that clockwise is negative, anti-clockwise is positive. This signs we have to remember while solving the problem. Okay, so here I am writing sigma moment about a point, which is equal to 0. So from here moment at this point RAX RAY is 0. Now I am taking here 141.14 sine 45 force is there. So momentum is nothing but force into perpendicular distance, which is equal to 0. Okay, and here force is 141.14 sine 45 into the perpendicular distance from here to here. So for this force perpendicular distance is this much, which is 2. So if the here the point, in this point we are taking moment. So if you see here force is acting here. So if we take this one, this moment is acting in, this one is clockwise direction. So here 141.14 sine 45 into 2, this is clockwise, so we have to take negative sign. Next one is here 141.14 cos 45 is there. So perpendicular distance is no, which is, this is going in line with the that point, so this is 0. And next one is 100 Newton meter. This force is in anti-clockwise direction, means positive 100 Newton meter. Okay, and next one is 20 force. This force also we are taking from here to here. So this force is acting in this direction. So clockwise means negative. So 20 into the perpendicular distance is from here to this point. So here 2 meter, 2 meter, 4 meter, here 1 meter. So total is 5 meters into 5. Next one is here 100 Newton is there. And from here to here also, this is also in clockwise direction. So from here to here it is taking, here clockwise direction is negative. So minus 100 into, so the perpendicular distance is from here to this point. So total is 6 meters. So 6, and we have this force, RB force. And from here to here, this force is acting in anti-clockwise direction. So plus RB into the perpendicular distance is total length from here to here, that is 8, which is equal to 0. Okay, from this equation we can find the RB value. And now I am going to find this. So I am taking everything into right hand side, this RB into this side I am keeping. So 8 into RB, which is equal to 141.14 sine 45 into 2 minus 100. Here this one, if we went that side, so place 5 to 100 plus 100, this is place 600. Okay, this is I am going to find in Calcino. Okay, and if you see, okay, if you see here 141.14 sine 45 equal to this much, this minus 100 plus 100, 0 plus 600. So we got this much, 699.8. Okay, So 8 into RB, which is equal to 699.8. So if we want RB, we need to divide with 8. So divide by answer divided by 8, we will get 87.475. So RB equal to, from here we got RB equal to 87.475 newtons. Okay, we got RAX and RB value. So from equation, if we consider this as equation 2, from this equation 2 we can find the RAY value. So I am writing here RAY plus RB is nothing but 87.475, which is equal to RAX 99.8. So from here we got RAY, which is equal to 99.8 minus 87.475, which is equal to 12.325. So 12.325 newtons. So we got every value, RAX, RAY and RB. So for finding a reaction force at point A, we have RAX value and RAY value. So for finding force acting on at one point, so we need to find the resultant force at A. So for that, reaction force at A, which is equal to and the root of, which is RAX whole square plus RAY whole square, which is nothing but reaction force at A point. So we know that RAX is 99.8 whole square plus RAY is 12.325 whole square. This is root. So we will calculate here. So here the root of 99.8 whole square plus 12.325 whole square, which is equal to 100.56 newtons. So RA, which is equal to 100.56 newtons. So we got the reaction force at A, but we need to know the in which angle, how much, in which, from we need to know the direction, in which direction. So for finding the direction, the theta is nothing but tan inverse of RAY by RAX, which is makes angle. This formula is with respect to x-axis. This formula represents with respect to x-axis. So tan inverse of, for tan inverse we need to click the shift and tan in. So shift tan inverse, tan, if you click the shift plus tan, then we will get tan inverse. So we need AY by AX. So RAY is nothing but, we got RAY is 12.325 divided by RAX. We got 99.8. So from here we got theta value as 7.04 degree. Okay, whatever it may be the values here we got, but the procedure is same for each and every problem. So if you want to find the reaction for, if they ask to find the forces at support reactions, then you have to find the resultant. First we need to find the reaction forces at that particular point, and we need to find the resultant force and in which direction is that force is acting. We need to find this much if they ask any problem. Okay, in this way we can solve the problem. Thank you for watching.